Let's talk about disproportionation reactions. So not only do you get to say a really cool word with these reactions, but you have one element with one oxidation state that simultaneously undergoes both oxidation and reduction. So in order for this to happen, it has to have at least 3 oxidation states within the reaction. So you look at the overall written out reaction, you should count 3 different oxidation states. And one must be an intermediate state, which means it can go either oxidation or reduction. So for example, if we have a solution of copper 1 chloride that sits in a beaker for an extended period of time, well, a couple different things can happen. First off, copper chloride, which is going to be Cu+, that Cu+, it can gain 1 electron and turn into copper solid. Where would it get that 1 electron from? Well, a different Cu+ could turn into Cu2+ and itself lose 1 electron. So what you have here then is copper both being reduced and oxidized. And these aren't the exact same copper atoms, they're just the same state of copper. So inside of the solution, of course, there's going to be billions upon trillions of copper atoms. Some of them will be oxidized and some will be reduced. And the overall reaction that we would have then is Cu+, and since there's 2 of them, 1, 2, that means you'd have 2 Cu+, that turn into both copper solid and Cu2+, which is going to be aqueous. So we can see the oxidation states are +1 for the original copper. This guy in the solid state would be 0, and that guy, of course, would be 2+. So we have 3 different oxidation states. Our intermediate would be the Cu+, because it could both be oxidized and reduced. If it was oxidized, where it's losing electrons, it would turn into Cu2+. If it was reduced, it would turn into Cu. Another type of disproportionation reaction involves the same element, but in 2 different states. So instead of having just Cu+, we would have metals that are in 2 different states. An example of disproportionation reaction where they're in different states would be like this, where we have solid iron and we have iron chloride. So that means we have Fe and we have Fe3+. Now here's an example of where you need to know your ions. What other oxidation states can iron exist at? So Fe3+, what else could that turn into besides just iron? Because if it turns back, that wouldn't be a disproportionation reaction. Alright, if you're thinking through and you said iron 2+, you'd be correct. So iron could turn into iron 2+. Now what would have to happen for it to turn into iron 2+? So it would have to go ahead and gain an electron, and that would turn it from the oxidation state of 3+ into 2+. Now the top part, the iron, that obviously can't gain any more electrons. It's going to lose them, so it can turn into Fe2+ as well. And in order for it to turn into Fe2+, it would have to lose 2 electrons, which means our half reactions don't match up, so we're going to need to adjust this one. So 2 electrons, 2 Fe, 2 Fe. So then our overall reaction, our 2 electrons would cancel out. And in total we would have Fe, which is a solid, reacting with 2 Fe3+, which is going to be aqueous, turning into, and you'll notice right here we've got 1 Fe2+ and then 2 Fe2+, so that means 3 Fe2+ overall. And once again, we can see the oxidation states. That guy is going to be 0. This guy right here is going to be 3+. And this last one over here, 2+. So we have all 3 oxidation states.